Okay, last lesson you learned about what R was. Can someone remind me what that correlation coefficient was? It started with a P. It was a person's name. Pearson's correlation coefficient, and it told you the direction of the correlation, positive or negative, and how strong it was. Now we need to deal with the coefficient of determination, which is R squared. It's related to Pearson's correlation coefficient because it's literally just R squared. So whatever Pearson's is, you times it by itself, and you'll get this one. However, why we use it is it allows a further interpretation of the correlation between two variables, as long as we know that it's a causal relationship. As long as we know that the independent variable does actually change the dependent one, then we can talk about this. So how do we interpret it? This should just go on your cheat sheet. This is how you interpret it. You don't really get a choice in the matter. The only choice you get is deciding which is the independent variable and which is the dependent one. So how do you interpret coefficient of determination, R squared? If two variables have a causal relationship, then R squared, when written as a percentage, is the percentage that the change in, whatever your independent variable is, explains the change in the dependent one. Again, it says here in red, put that on your cheat sheet. So that's a little hard to imagine. So I've got an example here. So can you put your little scientist hat on and pretend that you're trying to do the nutritional information on a muesli bar or something, where it says 400 kilojoules and stuff like that. So what this scientist is doing is measuring the nutritional content of a chocolate bar. They measure the number of grams of carbs in the bar, and they also measure the number of calories in the bar. While we're looking at that, which one of those two is the independent and which would be the dependent one? Yes? Good, because the number of carbohydrates in a chocolate is going to determine how many calories there are. So this is independent and this is dependent. Is it fair to say that that would be a causal relationship? Is it fair to say that carbohydrates definitely would contribute to more calories in the bar? So we've established there's causal. So once we've done that, these scientists found out that the coefficient of determination, R squared, was 0.6. So let's express 0.6 as a percentage. What would 0.6 be if it was a percent? Yes? 60%. So this suggests that 60% of the change in calories in bars can be explained by the change in the, what was the other variable? The grams of carbs in the bars. That's all you need to do. So the question in the exam might go, interpret the meaning in the context of this question, what the coefficient of determination means. You look at that number, you convert it to a percentage, so you times it by 100, put a percent sign, and then you have a think first, and you go, in the scenario, which one's independent, which is dependent, and then you go, okay, so the carbs is changing the amount of calories in the bar. This tells me that 60% of the calories in the bar is due to the grams of carbs, which makes sense because the bars only have carbs. They would have fat and they would have protein. So those other two would make up the remaining 40% of that explanation, okay? But they only measured carbs and calories. Does that make sense there? Okay, you have the calculator instructions. How do we find the coefficient of determination? It's exactly the same place you find Pearson's correlation coefficient. So I'm going to put some perfect data in. Where's the retirement tips? Damn. It's telling me, that ad's telling me something. Let's put some perfect data in. Can someone remind me, how do I put data into the calculator? What do I press? Stat, good. Well, edit. Let's put some perfectly correlated data in there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Can someone remind me the steps that I would take to find Pearson's from last lesson? What did I press now? I put the data in. You press stat again. Where do I go now? Go to calc. Lin Reg. You're forgetting that first step though. Have I turned on diagnostics yet? See? Because this is a fresh calculator. Your calculator probably has diagnostics on because you haven't reset it since last time. But this is a fresh one every time. So I need to quit out first. I'll go second, 0. Press D to scroll down. Turn the diagnostics on just in case. Diagnostic. Sorry, I stuffed that up. Diagnostic on. Diagnostics are on now. So now if I go stat, calc, lin, reg, you are telling me the right instructions. X data in list 1, Y data in list 2, frequency list is empty, calculate. Can you see how there's an R and an R squared? So Pearson's correlation coefficient says it's a perfect relationship. What this is saying is that 100% of the change in variable 1 would be due to variable 2. But we just made that up, okay? Now let's do it for actual data. So let's do an example. At a father and son camp, the heights of fathers and sons were measured. This was the data here. Calculate R squared for the data set and interpret its meaning. So I need to go on the calculator. Second, quit. How do I put data into the calculator? Stat. Edit. How do I remove this without having to delete 5 things? Go to the top, press clear, press enter. Go to the top, press clear, press enter. Now I'm going to grind. So you follow along. While I'm grinding these numbers out, you're going to do the same. So put these numbers in. 175 is the father because the father is responsible for the son's height. It's not the other way around. The son is not giving his genetics to the father. That would be weird. Okay? 175 and his son was 167. So this video is going to go silent now while I put the data in. Can you do the same, please? $170, $158. That was a short father and son. 167, even shorter. 162, 179, 170, 171, 180, 167. So I believe I've entered my data there. I'll give you some moments to do that as well. Have we entered the data? How do I find statistics about this data? Stat, calc, lin, reg. I already did the diagnostics on this calculator, so I'm not going to do it again. But do you understand why in last lesson I made it step 1? Yeah. Because it covers your ass if you just always do it. It's a bit longer, but in the grand scheme of things, it's 30 seconds. Okay? Lin reg, get in the habit of X being in list 1, Y being in list 2. Does it make sense that R squared wouldn't be 1? Because is there someone else responsible for your son's genetics? Yeah. It'd be your mum. Yeah. Okay? Their height would also determine. What this is saying is, let's interpret it. So R squared is 0.6832 to 4 decimal points. What would that be as a percentage? 68.32%. So now that phrase that I asked you to have on your cheat sheet, you would go, therefore, the data says that 68.32% of the change in sun's heights is explained by, what was the independent variable? The father's height. By their father's heights. That's all that is. So your exercises today are once again trying to get fast at getting that data in and interpreting what r squared means. There's only 3 of them today, I believe. So I'll stop the recording there. Yep, that's the only question there is. So that's coefficient of determination.